Area of triangle, we're going to skip that. We're going to come back to it at a better time. You're not going to learn about area right now today. We also have this law of sines ambiguous case, which, does somebody have their decision tree out? That sheet? So if you look on your decision tree, the decision tree has this whole side-side angle situation where if you follow it down, you actually come up with some more complicated solutions other than just the one solution. I made an executive decision. We're actually going to skip that, okay? If you take the college trig course next year, you will see that piece. I just don't think it's necessary for us to do that. So you're going to skip past this, and you're going to move yourself to the law of cosines. Law of cosines. So the law of cosines allows us to solve triangles if you're given, say, all three sides, or if you're given a side angle side. And the law of cosines looks like this. It's going to look very familiar to you. C squared is equal to A squared plus B squared. Does that look familiar? That's the Pythagorean theorem, isn't it? And the law of cosines is really just the Pythagorean theorem, but then it's got this extra nugget right at the end. We have to subtract something off. And what we subtract off is 2 times A times B times the cosine of angle C. Now what I'd like to do is I'd like to write a formula for B squared as well. If instead of C squared, if I have B squared, what do you think the next two parts are there? A squared plus C squared minus 2 times AC times cosine of angle B. Good. And finally, if you had A squared, that would be equal to B squared plus C squared minus what? 2BC cosine of angle A. If you look at your decision tree that you have in front of you right here, notice that you do have the law of cosine sitting right there. So you don't have to memorize these formulas you do get to use on the test. So let's see, today we want to solve one triangle. We're going to do letter B tomorrow, but today we'd like to solve one triangle using the law of sines. So, or law of cosines, excuse me. So I'm going to set this up. I've got triangle A, B, C, where A is 26 degrees, side B is 12, and side C is 15. Talk to the person next to you and classify what kind of triangle is this? Is this an angle side angle? Is it a side side side? Is it side side angle? What kind of triangle is it? Talk for 20 seconds, decide. Okay? What? Okay, you had two sides of one angle. The question is, does the angle sit between the two sides? It does. So therefore, it's side angle side. It is not side side angle. As you look at your decision tree right here, it says side angle side. There's one solution, and it tells you to use the law of cosines. How is this different from the problems we've done before with the law of sines? There's something really important that you need to notice here, something that you don't have that you normally do have. We have an angle, but we don't have its opposite side. You see that? Law of sines requires you have an angle and its opposite side. I do not have an opposite side, and because I do not have it, I cannot use the law of sines. So I want to find side A. That's the whole point here. Once I find side A, I can go back to the law of sines. That's where we like to be, right? Law of sines, it's nice and easy. This is going to look complicated, really isn't too bad. If I want to find side A, do you think I use the c squared, the b squared, or the a squared equals? A squared. So I'll set that up, and I will write down my a squared is equal to b squared, or 12 squared, plus 15 squared, minus 2 times 12 times 15 times the cosine of what? 26. Now, some of you have real calculators, and some of you have not real calculators, okay? It is going to be a lot easier if you have a real calculator. So, I see a real calculator here. That's a real calculator. Anybody not have a real calculator? Okay, so you're going to need one. The only two I have is I'll share there. Okay. So the benefit of having a real calculator is it understands order of operations. Your phone does not understand order of operations. So I'm going to type all this in all at once. Don't worry about trying to work all of it through or individually. Just type in 12 squared plus 15 squared minus 2 times 12 times 15 times the cosine of 26. You just type that all in, and your calculator is going to give you a nice result. I'll pause and make sure everybody has that first.
Should it be 45.43?
I press enter, and I've got 45.43. Is that the length of A?
Yeah.
No, that's A squared. So what do I have to do to that? Everybody pause, watch, don't get ahead of yourself, because I want to show you something that can save time. I'm going to press square root, okay? And then I'm going to take the square root of the previous answer. There's a button on your calculator that accesses the previous answer. It's right on the negative side. It says ANS. So if I go second answer, it grabs that piece. So I use that option a lot. And I get 6.74. So that means that side A is 6.74. Now, as we finish this off and we try to solve this, it's very important that you follow the next step. Please look at your decision tree. Everybody look at it, otherwise you ain't going to get this. Okay? Landon needs one. I got one for you, buddy.
My eye's spazzing. What are you stressed about? No, that doesn't cross my stress.
So, side angle side, it says, and make sure you follow this, it says there's one solution. Use the law of cosines. Is that what we did?
Yep.
Then after that it says, when you are using the law of sines to find one of the missing angles, which is the angles that were, what two angles are we trying to find right now?
B and C.
It matters which one you start by finding. You can't just choose either one. It says when you are solving for missing angles, start with the angle opposite the shorter of the two sides. Talk to your friend right now. Tell them, do you think you solve for B or C, and why? Go.
B is the shorter side. B is the shorter side.
Why?
The correct answer is you need to solve for angle B because it has the shorter side, C has the longer side. So we solve for angle B. So let's set that up. This is part of what you struggled with on the checkpoint. I have the sine of what over what? Okay, B over 12, we can do that, is equal to the sine of
26 over 6.
26 over 6.74. Again, you want to use an angle and its opposite side every time you're using the law of sines. So notice how I'm going to try to solve for angle B. So since I'm solving for an angle, I'm not going to cross multiply the whole time. I'm going to go sine of B is equal to 12 sine of 26 divided by 6.74.
Wait, what does it say? 12 sine of 26?
26 over 6.74. Let's make that into a decimal. So 12 sine of 26 divided by, parentheses, divided by 6.74.
I got that.
Is that my answer?
No.
What do you need to do with that? Sine inverse. Watch how you can save some time. I'll press second sine. Now what do you think I press? Second answer, and that brings that answer right in there. I get 51.30. That way you're not even rounding it all. It's grabbing the exact value. Question.
Do we have to close the
On the answer?
Yeah.
You don't. I get 51.30. So 51.30 is the answer for angle B. The last one I need to find is angle C. How would you do that?
You have to
Yep, subtract both of them from 180. So I have 180, and watch, I'll even use the feature again, minus the answer, and then I'll subtract 26 from that as well. And I get 102.70. So tomorrow we want to look at the next example, okay? And then we'll practice this later, but I want you guys, right now, we don't have time to go into that, but you can go ahead and try to finish off your law of sines worksheet from the other day, okay? Your law of sines worksheet.
Can you make me an e-haul pass to the bathroom, please?
I can.
Thank